Here we have yet another example of the washer method. So we start off with this region, which I'm going to graph right now. They're telling me that I have the line y equal 1. So here's y equal 1. X equal 1. That would be over here. And the parabola, which is y equal x minus 1 squared plus 1. So it has a vertex at 1, 1, which happens to be right there. And with a vertex right there, it tells me that's going to be going up like this and up like this. That's going to create a region here. It's really bounded. I think I have a x equals 0 in there as well. We're going to add an x equals 0. We're just going to bind this right here. It tells me that this is the region that I'm worried about. That's what I want to revolve. But this time they're going to revolve it about x equals 2. Well, this was x equals 1, so x equal 2 would be a little further over. That's going to be over here. I want to revolve this about x equals 2. If I revolve that about x equal 2, well, that's going to set up a whole new ball game here. I'm going to have to know what these y values are. So I know that this is y equal 1. Tells me I'm starting at y equal 1. I'm going to have to figure out where that is. If I set this x value equal to 0, because I said that's a y-axis, x equals 0. If I plug a 0 in there, that's negative 1 squared, which is 1. 1 plus 1 is 2. So it tells me that this point here is 0, 2, which means that would go to y equal 2. That's setting up my boundaries. Tells me where to start, where to end. But I'm revolving it about the line x equal 2. So it's this region that's getting revolved all the way over here. And so it's going to be basically a shape like this. I know those are hard to see. And you ask yourself, what about this part of the parabola? They don't want that part of the parabola because it was bounded here. This was the only part that was bounded. And so as I look at this figure, I'm going to recognize that there's going to be a void in here. This bowl shape, this white bowl, is not there. It's being removed from that solid cylinder. And so this is clearly a washer method. I can say my volume will equal the integral from y equals 1 to y equals 2. And now I have to figure out the nearest and farthest radii. So if I'm here, the farthest distance I'm going out is to there. Now, when I look at this, this is x equals 2, if you recall. 2 minus 0. 2 minus 0 would be 2 squared. So this would be pi times 2 squared. This is my original x and y axis. This is my origin. So this is x equals 0 right here. So that distance was going to be 2 minus 0. That's what I have there. That's my big radii. Minus pi. The smaller radii would be the distance from here to there. And I always want to do my right minus left. So in this case, it would be 2 minus that curve. But this curve is still in terms of x. It hasn't been solved for x. I need it in terms of y because of these right here. And so what I'm going to do is solve this for x. I think I can do that up here. I'm going to simply boot the 1 over. Be y minus 1 is equal to x minus 1 quantity squared. Then I'm going to root it. So this becomes plus or minus the square root of y minus 1 equals x minus 1. Then I need to move the 1 over. So it's plus or minus rad y minus 1 plus 1 equals x. Now, in a previous example, we were worried about the positive part of the parabola. I'm not on the positive. This time I'm on the negative. And so if I clean this up a little bit, I'm really looking at x equaling 1 minus radical y minus 1. That's the part of the parabola that I'm working with. It's this negative part here. And that distance then would be 2 minus all of that. And so when I do my formula down here, I'm going to go 2 minus, now this would be in parentheses again, 1 minus radical y minus 1 squared dy. Now let me clean this up before I go to put that in a calculator. This is going to go from 1 to 2. This would be 4 pi minus pi times. Now be careful on this. This whole thing's being squared, but I can simplify here. 2 minus 1 is going to be 1. And this part, minus a negative, actually becomes plus rad y minus 1. See, I'm just distributing this negative across there. 2 minus 1 was 1. Minus a negative becomes a plus. That thing squared dy. Now I can put that in my calculator, and I should be able to come up with a pretty nice answer. So go to my calculator. Let me clear everything out of here. And I'll simply say 4 pi minus pi parenthesis 1 plus the square root, remember these have to go in as x's, x minus 1, get out of there, square it, and then I can do my second and do my calc option, integration option, and I'm interested in what's happening from 1 to 2. So I start at 1, I end at 2, I get that little bit shaded in there, and this gives me a solution of 3.665 units cubed. And there's your 5th example of the washer method.